This lecture will explain the rule of transposition for the conditional. This is also sometimes called the rule of contraposition, but we're going to call it, our text calls it transposition, so that's what we'll call it too. And it's going to be abbreviated as trans. And the way the rule works is this. If you have the formula P arrow Q, well, that's equivalent to the formula not Q, arrow, not P. Likewise, and so this one has 4 dots, so it goes both ways. So if you have not Q, arrow, not P, you can get P, arrow, Q. Now, if you have the formula not P, arrow, Q, you can still do this version of transposition on it. So you can turn it into not Q, arrow, not P. Or you could double negate the Q, so you could turn it into double negate the Q, so it would be not P, arrow, not Q, and then you can do this version of the rule of transposition on it. And so what you would get would be not Q, sorry, no. I mean, you could do that. You could do what I'm doing, but that's not using this version of the rule. Sorry. When you use this version of the rule, what you end up with is something that has less negations than you started with. Has one less negation. So what you'd actually end up with is not Q, arrow, P. Because when you do the transposition, one of the negations comes off the not Q, and then the negation comes off the P. And you can see that if you did double negation on this formula here, on the not P, you'd have exactly the same formula. So there's a number of different ways you can do this and get the same results in a series of steps. Okay, now I want to talk about a rule of transposition for the biconditional. And this isn't in your text. But it's a valid rule, and it could come in handy at certain times. So we're going to call this B-trans to differentiate it. And it'll work exactly the same way as transposition for the conditional. So if we have P double arrow Q, we can perform B-trans on it and get not Q double arrow not P. Likewise, if we have a negation on only one side of the biconditional, well, we can do this version, use this version to this version, and get not Q double arrow not P. Or we could double negate the Q, so we have not P double arrow not Q, and then we can do this version, and we would get not Q double arrow P, which, as you can see, is the same thing as this formula, except that it's as if you'd perform double negation. So when you have a formula that has only one negation, a negation on only one of the sides of the biconditional, you're going to either do double negation and then transposition, or do transposition and then double negation, depending on what it is that you want, too. I mean, if you want a version that has 2 negations on something, then, obviously you could just do the transposition. So it depends on what you want.